Hello all, welcome back to Data Science Brain. In this video, we will be seeing how to do indexing and selection of a data frame using Pandas. In the previous video, we have learned how to handle duplicate data, and before that we learned how to handle missing data in a data frame. And let's get started. So, as usual, let us import Pandas as PD. And you have to connect here, you know that. So let us import the library. So let us first create a dummy data so that we can learn how to do indexing and slicing. Okay, I mean selection. So as usual, let's create some names as we have done in the previous video. Let's say Deepak. Let's say Josley. Let's say Divya. Let's say Jins. Say Ebin. Dawn. Dojo. Okay, so these are some names, and let us say, I mean, there are too many names, right? Let's delete these three. And let's create the next column. So by this time you must be knowing, I mean, we have done, I think in the first video we have learned how to create data frame using dictionary, right? So I hope you know that. So let's say 20 20. Okay, I'm 24 20 21. Okay, we don't have this, we don't need this. Okay, let's say 28 30. Okay, so we have some ages of these people, and let's now say the city where they live. Say Kochi, Alapi. Let's say um, Todupuzha. Let's say Bangalore. Okay, let's say Chennai here. Okay, so we have created this data frame. Its name is df actually, and let us now print it and see. Okay, we need to okay, sorry, we need to make it a data frame first. So you know how to make data frame, right? pd dot data frame. We need to call the data frame function and pass in this dictionary, and then we will get a data frame. Okay, it's a beautiful data frame with name, age and city as columns, and it has 4 rows. Okay, so now let us see how we can use square brackets to access some of this data. For example, let's say I need to access name. Okay, let's say I need to access all the values in name column. So it is so simple. You just need to write in name here, and we will get the name column. Okay, and let's say we need to access multiple columns. I need to access name and age. So for that, we will just give here an array of columns, array of names that we need. I mean, array of column names that we need. Okay, so we will pass in name and age here, and we will get name and age as a data frame actually. Okay, the previous one was series. Okay, actually we can check the type and ensure that this was actually indeed a series. Okay, so let us check the type. So it's a panda series as I have told you. So let us check the type of the other thing as well. So let us see, let us check what will happen here. Okay, let's say what will happen here. It will be a data frame. Okay, so here we are saying that we need this particular column, otherwise we are just passing in the name, we will return, I mean it will return at a series. But if we give it as a array of names, it will return us a data frame. Okay, okay, so that's about using square brackets to access different columns. Next, let us see how we can access data from a data frame conditionally. Okay, for example, let's say we need all the data in the column I mean all the data where age is greater than 21. Okay, we don't need 21 age people, we need age greater than 21. Okay, so for that what can we say? I mean, what can we do? Simple. It's just like, pure English. We are saying we need from df, we need, we are selecting the age column and we are saying we need all the data where age is greater than 21. Okay, that's what we are saying. And let us see, we have received all the rows, all the data with age greater than 21. Okay, so that's how we use conditional selection. Okay, so what happens here is that, so this will return boolean values. Okay, we can print this actually. So this will return couple of boolean values. So when we pass in this boolean array to this, it will return all the rows where it is true. Okay, so in the first, I mean the second row, it is false, so it hasn't returned that. All the other rows has true in it, so it has returned all the other rows. Okay, so that's how we use boolean indexing. Okay, so I will make you understand this a little bit more easier. So let's say we are passing in, uh, let's say like true, false, say okay, let's say false, false. Okay, let's say this is what we have given it. So it will return only the first one because only the first one is true. Now if we make this one true, it will return the second row as well. Okay, so that's what that works. Okay, I hope you understand that. So that's how we can use boolean indexing to access rows based on particular conditions. Okay, conditionally accessing rows. We can say here something like a little bit more, something like, maybe we can also say we can use any kind of operations here, right? We can say greater than or equal to, or let's say less than or equal to. This will return only 21. Okay, oh, I think I have made a mistake. uh, Saying there are no rows with age less than 21. What happened there? Okay, so it has, I have added additional like a list there. Okay, so I hope you understand that. Now let us see how we can set and reset index. So now we can see, here in this data frame, it has automatically indexed it, right? It is not using any of these columns as index. It has given it an index on its own, 0 1 2 3. Okay, now maybe, I need the name column to be the index of this. So for that we can use another function called set index. Okay, so let's say df dot set index, and which column do I need? I need the name column to be the index of this. Okay, and I will type in place. If I type in place is equal to false, what happens is that it will affect this particular data frame. Okay, it won't return anything, but it will place this in the same data frame. Okay, so after we do this and we print df, we can see name has now become the index. Okay, see, name has now become index. Now let's say we have accidentally done that and we didn't need it. So how do we reset it? So for that we can use reset index function. Okay, so set and reset. So we run that and it has reset the index back to the normal 0 1 2 3. Okay, so that's how we set and reset index. Now comes two most important topics, indexing and splicing using loc, iloc, and at. Okay, so loc and iloc is used for multi-column indexing. Okay, so it is used for indexing. It is used for getting multiple column and row data, and at and iat is used for getting scalar data like single data. Okay, so let us first look at loc and iloc. Okay, So both loc and iloc are really powerful tools for selecting data from data frame. Okay, but they operate differently based on how they handle the indexers. So loc is used to handle data using, to index data using label, like label based indexing, like name, age. These are all labels, right? So iloc, this I represents integer. So iloc is the only difference between loc and iloc is that iloc uses integer indexing. Okay, so integer based indexing. So that's the difference. So loc is label based indexing, iloc is integer based indexing. You can differentiate both of them by using this I in the iloc. Okay, so whenever you see I in front of loc, it means that it is using integer based indexing. Okay, that's the only difference. So let us now see an example. So before that, let me mention one more thing. So whenever we use df.log, the first thing that we should pass in here is the row indexer. Okay, and the second thing will be, after a comma, will be the column indexer. Okay, so what this means is that this is indexing the rows. So here we will pass in the labels of rows. Okay, and here we will pass in the labels of the columns we need. Okay, okay, so now let us see example. Okay, let's say we need the we need all rows. So since we know that, for by using iloc, by using loc, we need to give it the labels of the rows, but we don't have labels of the rows, right? We have a default indexing here, isn't it? Okay, so one more thing, I need to place in place equal to true here in order to replace, reset the index for this particular data frame. Otherwise this will just return a data frame. Okay, it won't change the same data frame. So I need to pass in place equal to true. Okay, now let us see some examples. So we have learned here, first we will pass in the row indexes, right? So we are passing the labels of rows that we need. What are the labels of our rows? So these are the labels, right? 0, 1, 2, 3. These are the labels of our rows. Like that's what we call our rows. Okay. So 0, 1, 2. We are saying that we need 0, 1, and 2 rows, and we are saying we need these columns, name and age columns. Okay. So here we returned 0, 1, 2, 3 and age and name and age columns. Okay. So that's how we use loc, and we pass in the labels of the rows and columns here that we need. First we'll pass in rows, second we'll pass in columns that we need. Okay, and we can actually pass in single as well. Okay, we can say we can access scalar values, like in the zeroth column, uh, I mean we need zeroth column, and we need all the we need the name there. Okay, so in the zeroth column the name is Deepak. Zeroth row, the name is Deepak. Okay, so we can use scalar indexing also by using loc. Okay, so I hope you understand that. We can also use boolean indexing with loc. Okay, so if we pass in some boolean values here, like let's say how to create boolean values, we have learned it in the previous section, right? Let's say age greater than 21. So we know that this will return set of boolean values, right? And we are saying for, I mean we need the names of those people whose age is greater than 21. So this will return Deepak, Divya and Jins. Deepak, Divya and Jins has age greater than 21. Okay, so that's how we use Boolean indexing with loc to get data. Okay, so that's about loc. Okay, I hope you learned about loc. So basically we are passing in the labels here. Okay, so loc is mostly used for indexing using labels, like we are saying 1 and 2, and here we are saying we need name and, okay, one more thing, name and age. So we are passing the labels of the rows and labels of the columns. Okay, so that's how we use loc. And let us now shift to iloc. Okay, let's see how to use iloc to index a data frame. So as I have mentioned, iloc is integer based. So instead of giving the names here or the labels here, we are going to give integer values here, like 0 and 1. what do you think this will return? It will return the 0th row and column 1. Okay, it will return the value at row 0 and column 1. So what is at row 0 and column 1? It is 24. Okay, so it has returned 24. We can say 1 and 1. So it will return the first row and first value. Okay, I mean in reality the second row. Okay. Okay, so that's about that. Now we can use this for more little bit advanced indexing. Like we can say we need all the rows till the second row. Okay, so this will return this will select the first two rows, and we are saying all the columns starting from the first column. Okay, so it has returned all the rows till the second row and all the columns from the first column. Okay, starting from the first column. So it will return age and city starting from first column and second column till the second row, 0th and first row. Okay, so that's how we use like this is called slicing. Okay, so we are slicing the rows till the second row, and so I think slicing the columns from the first column. Okay, so that's how we do that. And one more thing we can use iloc for is just like the previous one, we can pass in multiple values here. We are saying that we need the 0th and the second row, and we need 0th and the second column. Okay, so this will return Deepak Divya and these two. Okay, so that's the difference between iloc and loc. Iloc uses integer. I stands for integer indexing. We are passing in integer numbers here. Okay, we are saying 0th and second row, 0th and second column. And in loc, what we did, we used labels. Like the label for the first row is first and label for the second row is 2. We are passing in those labels there, and the label for the first column was name and the label for the second column was age. So we passed in there and we got this in return. Okay, so loc uses labels, iloc uses integer for indexing. Okay, so that's about those. So next let us see at and iat. So at and iat is used for scalar indexing. Like we need this particular value. Let's say we need the value at first row, or I mean we are using 0 indexing. Okay, so let's say second row and second column. Okay, we need the value at second row and second column. So what we'll do? So we will use at here. Let's say at. So df dot at. Let's say what is the label for the second one? It is 1 and 1, right? So since this is 0 indexing, it will be 1 and 1. Okay, so 1 represent the second row, and for the columns 1 represent the second column. Okay, so just like loc and iloc, at and iat. Okay, oh, there is some issues here. Oh, okay, of course. This should be name. Okay, we have it. So just like loc and iloc, the difference between at and iat is that iat uses integer indexing, at uses label indexing. Okay, just the same. Okay, and this is used for scalar indexing. So we have returned the value at second row and column name. Okay, let's say we need the third row, or let's say in terms of 0 indexing, the fourth row and the value at the last column, that is city column and fourth row. City column and fourth row. Let's get the value at city column and fourth row. Because of 0 indexing, it's 3. So what is the value at city column and fourth row? It is Bangalore. Okay, so that's how we use at to get scalar values. Okay, so it's same as like loc and iloc, just for scalar values. Okay, the difference is that it is used for scalar indexing only, not multiple indexing. Okay, multiple value indexing, just for scalar indexing. And similarly, we can use iat. We know the difference, right? I mean, the only difference is that this uses integer indexing. So instead of passing the names or the labels here, we are going to pass in pure numbers. So what will 1 return? Since this is 0 indexing, it will return the second row and the second column value. Okay, so what is the second row and second column value? Second row, second column, it is 21. So this will return 21. So yes, this has returned 21. Okay, so the only difference is that it will use integer based indexing. So if we pass in 3 3 here, this will return the last value, isn't it? So because of zero indexing, the third row, row 3 means it is the fourth row, and column 3 means, there is no column 3, okay, 0 1 2, it will be 2, it will be Bangalore. So if we need to get Bangalore, we need to pass in 3 and 2 here, okay. So we have returned Bangalore here. Only difference is that IAT uses integer indexing, AT uses label indexing, okay. So that's all. So next, let us see how we can use some functions for indexing. Let us write a function filter age, and it will take in a data frame, and it will return in this data frame where the age column has values greater than 21. So this will return all the values greater than 21 in the age column, okay. So let us print this and see, okay. Let us print this and see what this will return first, and then we will use it for indexing. Let us pass in df here. First we need to run this function. It has returned true, false, true, true. So let us check. So we have set greater than 21. So this row will return false and all the other rows will return true. So that's what we have received here. Now we know that we can use loc for a loc with Boolean indexing. So if we pass in some Boolean numbers, Boolean values here like 2, true, false, false, true, what this will return? This will avoid the two rows in the middle, and it will return the first and last row, right? So it will return first and last row. It will avoid these two rows. So if we can somehow get a function to return some Boolean values as an array here, we can use that for indexing, right? So that's how we use function for indexing here. We will pass in this function here. Okay, just like this, we will just pass in this here. So this will take in the data frame as a value, and it will return a list of Boolean values here. We have run this and we have seen, right? I will again run this and I will show you. If you pass in df here, what this will return? It will return a series of true false values, right? So this will take in the function like this here, and we will pass, this will automatically pass in the data frame to it, and it will return the true false array here, and this will filter it, okay.